So the first formula is the sum of all the interior angles. The sum of the interior angles, you do n minus 2, the sides being n, times 180. So when they just ask for the formula, there you go. That is the formula. When they say it's a 35agon, what's the sum of the interior angles? You plug in 35. For something like number 4, and they say, hey, it's a heptagon. First of all, you should know heptagon. It should be how many sides? 7. So you're going to say 7 minus 2 times 180, which gives you 900. And they gave you 6 of the 7 sides and said, hey, what's the 7th? Or 6 of the 7 angles, what's the 7th? Well, you take 900 and subtract the 6 angles they gave you. All right? So they're basically giving you the same question over and over and over and over. Sum of exterior angles, that's always 360. Always 360. So then they start asking you about exterior angles. And then they give you some interior angles and exterior angles with variables, okay? So like for number 11, that's an 8-sided figure. So you would plug that in, 8 minus 2 times 180, 1080. And then you would add up all your angles and set it equal to 1080 and solve for x, all right? For number 12, it's a regular, meaning all the angles are the same. If you wanted one interior angle, you would just take your total, which you have right here, and you would divide by your n. So if you wanted one interior angle, you would take your total angles and divide by how many angles you have. And so for number 12, that 5-sided figure, those are all the same. So they just took what they had and they just divided by the number of angles that they had. And then for 13, those are exterior angles, so they set it equal to 360. So this whole first page is using these two formulas. And then they're using the fact that exterior angles add up to 360. So the only other thing you need to know is that exterior angles always equal 360 degrees, always. All right, so the sum of the interior, that's your n minus 2 times 180. If you need just one interior, you divide that number by how many angles you have. And if they're talking about exterior, that's equal to 360. But every single question from 1 to 13 is talking about this thing right here. All right, your sum of your interior or your exterior. All right, properties of parallelograms. This is true for all parallelograms. Parallelograms, rectangles, rhombus, square. Okay? This is true of those. Your opposite angles are congruent. Adjacent angles are supplementary. They add up to 180. You have opposite sides are parallel. Diagonals bisect each other. All right, so if it just says this is a parallelogram, these are the things you can assume about it. All right, if it gives you something more specific, then there's more things you can assume, all right? But if it's just this parallelogram, you have all of this information that you can go by. They're going to give you angle measures, they're going to give you side length measures, and they're going to want you to come up with the others based on these properties, all right? If they say that it is a rectangle, you have some more information. Obviously, your opposite sides are equal, the opposite sides are parallel. You still have diagonals that bisect each other. You still have opposite angles that are congruent, except in a rectangle, all 4 angles are congruent. They're all 90. Diagonals are not only bisecting each other, they are also equal, which means every single piece of the diagonal is the same length. In this case, you're also going to have some right triangles. So here's where you're going to potentially see Pythagorean theorem. If they give you a base and they want the diagonal, or they give you the diagonal and they want one of the sides, they're likely asking you to do Pythagorean theorem, okay? So when you start throwing in right angles, look for a missing side of a right triangle, Pythagorean theorem. Rhombus. Rhombus has all the properties of a parallelogram. It does not have 90-degree angles. Some things that are unique to the rhombus that then go on to the square is your diagonals are perpendicular bisectors of each other. So while the diagonals are not equal, like in a rectangle, they are perpendicular to each other, which means you do have right angles in a rhombus. It is just created in the center here. It is not created on the sides. So here you have the right triangle. All right, you still have bisecting here. So that means this side is congruent to that side, this side is congruent to that side. You still have a right triangle, and you could potentially use Pythagorean theorem here as well. Something else unique to a rhombus that moves on to a square is that these bisect the angles. So not only do the diagonals bisect each other, they bisect the angles. So here they could give you an angle measurement, and then they could just assume, you're just going to assume that the other side is congruent. Or they could give you the total, and you could cut it in half to find one of the smaller ones, all right? You still have supplementary angles here that are adjacent, all right? And you still have congruent angles that are opposite of each other. But then you also have bisecting angles. Don't forget, with every parallelogram, you have potential alternate interior angles. So if I have parallel here, that means I have alternate interior angles. These are alternate interior angles. And so you may also have to use that with some of these. And then the square, right, combines your rectangle and your rhombus. So you have 90 degrees. You have bisecting and equal diagonals, and they are perpendicular bisectors as well. So you have right angles here and right angles here, potentially Pythagorean theorem for that. All right. And then after your quiz, this was all on your last quiz, we also have trapezoids. Trapezoids have 4 sides and 4 angles, obviously. You have only one set of parallel lines, unlike the parallelogram. All right. Adjacent angles add up to 180. All right. These are not, for just any trapezoid, these are not congruent. Your base angles are not congruent for just any trapezoid. It has to be an isosceles, okay? So for any trapezoid, you have the adjacent angles that add up to 180, but you do not necessarily have congruent ones, all right? That's only on the next one. Median we talked about. For any trapezoid, right, you have a potential median here. All right, for your median is going to be based on your 2 bases, right? So you take your median and it is equal to what? What is your median equal to? It's a formula here. And this, remember, your median is equal to your bases added together divided by 2. All right? So your median is equal to your bases added together divided by 2. So whether they give it to you numerically or whether they give it to you with a variable, your median equals your 2 bases added together divided by 2. So if I'm trying to find something, I can multiply both sides by 2 to get rid of my 2 in the denominator, combine my like terms, solve for my variable. That is your trapezoid. For isosceles trapezoids, you have congruent base angles. So this angle A is congruent to this angle B. Angle D is congruent to this angle C. And so you also have the legs that are congruent here. Remember, for a trapezoid, your median, all right? So don't forget that your mid segment is the one in the middle. Your bases are the ones that are on your parallels. Your legs are over here. All right, and your mid segment hits at the midpoint. The last one we did was a kite. 2 pairs of adjacent equal sides. So the sides that are adjacent are equal on a kite. So adjacent sides are equal. 1 pair of opposite angles are congruent. So the angles that are created by the non-congruent sides, so this side and that side created this angle. They are not congruent sides. The angles are congruent, all right? Your diagonals are perpendicular to each other, with the longer diagonal bisecting the shorter one. All right, so this diagonal bisects the shorter diagonal. All right, and you create some congruent triangles here because these are right triangles with hypotenuse leg. So these end up being congruent. These are right triangles with hypotenuse leg, so these are congruent. And so you have to start using your knowledge of congruent triangles as well. All right. You don't have as many properties to worry about with kites, but they're a little bit different than what you're used to. The last page is what we did with the first group of sections, but it's at the end here, telling me what type of figure you have. You want to use your distance formula here. You're going to base it off your side lengths. Are they equal? Your diagonals, are they equal? We didn't do it with slope, but if you want to use slope to prove that you have right angles, you can do that as well. As long as you have given me the most specific quadrilateral that it can be. Meaning if you said, hey, this is a parallelogram, but I could prove that it was a rhombus, you were not specific enough. All right? You were not specific enough.